This is George Sicalius, and this is Sprint 2. So, here I have two ABBs. If I collide with the other one, it detects a collision. Then it moves according to the tank. If I switch to a B sphere, it also detects collisions. And yeah, as for added features to my demo, I broke my tank into two separate objects. So the bottom half and the top half. So it functions more like an actual tank. But yeah. So actually looking into the changes within the collision system. So I removed all the B-sphere specific stuff inside of test pair and test self. I'm getting my intersect by passing in the collidables. This then gets the collision volumes attached to these collidables. Using the visitor pattern, it's able to get the actual class instead of just referring to the base class of the collision volumes. So let me actually... Okay, yeah, that doesn't work. So this is math tools. I have a couple new Boolean methods for specific intersects, B-sphere versus B-sphere, ABB and B-sphere, and ABB and ABB. I have a couple helper functions, and yeah, and then this is intersect, which is called inside of the test pairs. So this just gets a generic collision volume. Is it called? Oh. Oh yeah, I renamed. Okay. Nothing. Ignore that. So it gets the collision volumes. It then calls the intersect except on the one of the collisions, which calls the intersect. This is a blah. It's a virtual method of collision volumes, which is explicitly defined for each of the types of collision classes. So ABB has an overloaded intersect except, and B-sphere also has an overloaded intersect except. So then that calls. So then that has, depending on whatever other is, it calls whatever either the intersect for ABB and B sphere or ABB and ABB. So yeah. So looking back at my math tools. So as I mentioned, I have a couple helper functions. Clamp point, it's used to clamp, well, it's pretty self-explanatory. It takes a point and then it clamps it to a given ABB. And then it stores that new clamp point inside of results. And then check back distance against flow. Okay, that's terribly named method. What this does is it basically takes the distance between 2 points and compares it with some float value, and sees if it's if the distance between the points is shorter than the distance is less than the float distance. So this is used for whenever a B-sphere is being used for collisions. So yeah, I'm using it here, and then I'm using it when testing it against a AABB. So yeah, that's math tools. So yeah, that's is there a pattern transpace? Yeah. Okay, so I'm now gonna go on to my graphics system. So visually, I don't have anything really different than last week. I just ran. Okay, fine. It's probably going to take a while to build. Okay, there. So I have a ship, I have a plane, I have lighting, and yeah. Oh jeez. That's not supposed to happen. So I think I said this last week, but my original plan was to basically start off with what I had last quarter in graphics programming, that graphic system in DX, and then basically throw what we had the first week of Engine 1 on top of that DX application. So yeah. So actually looking engine side inside of my graphics portion. So I managed to move out a lot of systems out of my starting engine. So I have all my asset managers, excluding images, my camera managers, game objects. I just have updatable and drawable, my scene manager, and yeah. So it's almost working similarly to my other project that uses Azul, except it uses DirectX. Of course, there's still a lot of stuff that I have to do. So yeah, actually looking at DX app. So what I'm probably going to work on this week is actually getting my engine to derive from DX app. I'm pretty sure that's how it's supposed to be done. As of right now, DX app is kind of its own system, and it just makes calls to my engine. Well, yeah, they're more or less hard-coded calls. It's not necessarily clean, so obviously I have to clean that up. So yeah. But yeah, like my engine works essentially the same way as in Azul, minus a lot of the features. So yeah, load content is called init, in DX app, in the draw scene. That's when draw is called inside my engine. In update scene, that's when update is called within my engine. And yeah. Share manager, okay. And so I had a couple problems with importing some of the assets. Let me pull up resource loader. So model manager, loading in models, game engine side, that wasn't really a problem. I mean, they took inside of the graphics engine, they took constant characters, so that didn't really change at all. Textures and shaders, I'm doing things a little differently. So I have to look into how to split up a white character, because obviously I don't want to have to make these large path, write out these large path strings to access a texture. I just want to store this inside of my texture manager and then just call this on load to load it in. And yeah. And then shader manager. So shaders inside of, well, at least how we set them up in graphics programming. We have actual classes for the each specific shader, and each specific shader has its own specifications when it comes to its layout, how many buffers it uses, and yeah. So yeah, since we're already passing the file name inside of the actual shader class, and given the fact that I'm pretty sure we're only ever gonna, if we're not gonna have two instances of the same shader, so what I'm doing is graphics side. I created a graphic shader manager, which it's a singleton which stores all of the shaders, and then they're stored inside of a map and then accessed through a string. So inside of resource loader, this is really just the string that corresponds to the shader inside of graphic shader manager. So yeah, as of right now, I just have I'm just working with a shader texture light. I have to also include the other shaders, but I figured if I could get one working, then getting the other ones shouldn't be that much harder. Just ignore this stuff for now. I have to move out all the light initialization. Yeah. So yeah. Oh, for actually rendering the objects. So in draw scene, I call draw on my engine, and then I call execute. So what happens in draw is, let me pull up. So it calls the draw on the actual game objects. So yes, this is exactly the same to the Zool call, except for what actually happens. I don't know what happens for sure on the Zool side. So this calls render and it passes its camera. So this doesn't actually render the object. It passes a... That was not what I intended to do. It passes a... Where's texture? There. Okay. So render doesn't actually render the texture out, the graphic object. Each graphic object has its own draw command, which stores its shader and its it stores its shader and its camera and the object. Yeah, and the actual graphics object. And then that is then passed to its corresponding shader. So each of the shaders store their own so they store a list of commands corresponding to the graphics objects that are using them. So yeah. Yeah. So right there. So then those graphic objects are stored, those commands are stored inside inside their corresponding shader, with their camera to be used to render them, and the actual graphics object and the shader. And then when DX app calls execute, this then calls execute on all the shaders. And then each shader will then set itself to context, render all of the objects that correspond to that shader, and then it'll go to the next shader. So execute, this is execute for the draw command. So it sets all its buffers, and then this is where it actually renders the object. So I chose to do this just to limit the amount of calls to the GPU, just the back and forth between the CPU and the GPU. And also I felt like this would give me some flexibility in case I wanted to, for some reason, render one shader before another. And yeah. So yeah, that's basically what I did this week. So yeah, moving forward, I'm gonna make my actual engine class derived from engine, and then make that derived from DXApp. Also, I'm gonna have to look into how to render wireframe objects. I believe I'll have to mess with rasterizers or create a new one, and then probably maybe I need to create a new shader for that. Also, I have to figure out how to properly handle images. Just figure out how they're different from textures. And yeah. So yeah, that's what I've been working on this week.